Let's see, what is this? What are we talking about here? Oh, that's easy peasy. All right, I'm gonna have Merrick look at that here in a sec. But anyways, so these 1/2 inch panels, what I'm gonna do is use the box tool. And I'm using the endpoint right here to start off our veneer panel. And I can click the opposite corner here where the 2 steel plates would technically be, like I'm kind of connecting the dots between the steel plates here. I'm going to continue to do that all the way through. Like that. And then from here to there. Okay. And then from there to there. Oh, kind of. Ugh. Ka-chow. All right. There we go. So let's go ahead and put these on the right layer. Right now they're on the rib layer. They should be on the veneer layer because that's what they're going to be made out of. So let's go VNX. And then one last thing we need to do here is we need to put in those little 8x8 corks or curves, whatever you want to call them. We're going to route those through these panels here. And we can do what we did earlier this morning, get some more practice with that. We can take the coordinate section of our solid editing toolbar. We're going to go down to here, this face icon here, the third one down from there in the bottom left corner will give you the option to select a face of the new XY plane that you'd like to start up. So we're going to click that, hit accept. And then just like we did on the other landing, we're going to take a rectangle, 2D rectangle here, and we're going to go 0.125, hit tab, and then 0.125. And then what we can do is we can copy these all the way across. And we're going to do that same method of approach where we had used the press pull command earlier today to be able to, whoops, I pasted that on the wrong side, didn't I? Dang it. All right, here. All right. There we go. Okay, cool. We have all those in place. I'm going to go ahead and save real quick. Not that I don't trust AutoCAD not to crash, but I'm going to save it anyway because it's a good practice to get in the habit of. If you are working on a model, especially if it's complicated, you're going to want to make sure that you save often in case you do lose anything, because you don't want to end up in a case where you got to go back and you got to redo a bunch of steps that you've already done. Kind of a waste of your time and a waste of company time. So you want to be sure not to not to get a place where AutoCAD crashes and you just lose your work. So always important to save as often as you can remember to do so. Now, AutoCAD will auto-save anyway, but sometimes it doesn't always get every little thing. So there are tricks to get your drawing back if that ever happens to you, but it's easier just to make sure that you do hit save every once in a while to make sure you don't run into an issue like that. Okay, so like we did earlier, I am deleting all these extra red rectangles that we drew in. They're no longer needed. They have served their purpose as far as getting rid of the material to run that curve cut through these panels. So they're gone. All right, so let's unhide, bring everything back, and we should be left with the new landing. So, you know, if I would have known these were 2 separate ones, I could have been paying closer attention. But what I'm going to do here is I'm going to block it anyway, just to be consistent. I'll specify a name first. So we're going to call this landing 2. Pick a base point, pick this base point right here. And then I'm going to rotate again just a little bit so I can see everything here. And I'm just going to select all of that. I hit OK, and boom. Now we have a nice block for the landing. Same thing up there. So each landing has its own block, and then each tread, except for these top ones, is sharing a same block reference too. And then these two top ones are sharing a block reference as well. So right now we're dealing with 1, 2, 3, 4, I think 4 different blocks for this whole staircase. All right, cool. Let me erase these lines too. Right now they're not needed. They can go away. Boom, they're gone. All right, but let's see. We do have one more thing to do. We got that planter at the bottom. We got to kind of have to look at here. So as a group, let's take a look back at their model. Okay, I'm going to isolate everything, bring it all back. Okay, and we're going to take a quick look at this little staircase planter at the bottom. All right, so before we hit the planter, we should have 1, 2, 3, 4, 5, 6, 7, 8, 9 treads, 1 landing. And then we have 10 and 11 down below. Going back to our model, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have the correct number of treads, but these two down here are actually going to become part of that planter. So again, we don't have all the information for that planter, but we can kind of sketch in roughly what they have here in this blue representation of the planter, and we'll run with that. It's the best we have for right now. The architecturals actually do show that same planter in their drawings. It's just, again, nothing is actually detailed out for it. So we're just going to try to utilize any information that we can possibly get off of this model here. So I'm going to start by pulling a distance from that corner out to, come on, if I can get to it, that corner there. Okay, one sec. Okay, so we're dealing with 70 inches wide. Okay. It does appear that the planter is centered on the stairs. So like from this side and this side, we have an equal measurement of overhang. The height difference from here to here should still be the same at 6 and 9/16. That should not have changed, but we can check it anyway just to be sure. 6.5833 or 5625. Okay, so it seems a little different, but it should be the same regardless. All right. Oops, I didn't mean to delete that. Help. Oh, there it goes. 70 inches wide. Okay. Okay. So let's check out what we have for the footprint of this planter too. So we know that it's 70 inches wide on the short side. Okay. And then we need to find out from this corner, whoops, to that corner, we're dealing with 261 inches at the longest, or at the floor, so 261. And that gives me sort of the footprint of what we're dealing with here. And that's all that I really need for the time being. I just need to know 70 inches wide short side, 261 inches long on the long side. That's enough for me to roll with what I need to do. So we'll go back to our model here. Okay, and I will keep these two blocks in here temporarily as placeholders because that's really what we're going to need for locations of treads. Now they will be a little wider because I think our treads are, let's see, I don't remember what they were off the top of my head. Ooh. Okay, I think 65 is what we had. Anyways, so actually I could have just measured it here. It would have been so much easier. I don't know what I was thinking. 65. Okay, so the planter is 5 inches wider in width compared to the original treads that we have drawn here. So what we can do is we know that this tread should be 6 9/16 from the floor. So let's go ahead and draw a line at 6 9/16 straight down in the Z direction. And we'll do the same thing here. Whoops. Okay. Now, based on the measurements that we just pulled from the model provided by the metal vendor, oops, got to switch back to my WCS, flip my view cube back to the top-down view. And I'm going to drop in a rectangle here. We're going to draw it at, let's see, 261 inches wide, or long, sorry, by 70 inches this way. And we want to make sure it's the same height as the bottom tread for right now. So this red box, I have to center it still along the front of this planter. Or sorry, the front of that tread. My goodness, I'm getting all my terms mixed up. You know, it's time for coffee when that happens, but all right. So we've got that. I can essentially remove that tread that's no longer needed to be there. Get rid of these two lines, they can go away. And then that leaves me with the base of my planter. I have one more step to create, which would be that step that's right here. And what it's going to do is pretty much just add on to the existing structure of the stair. It only has a step at this front. Everything else is straight up and down vertically from the floor. So that helps me out because what I can do is actually what I could probably just do is just copy this straight up like that. See what I'm doing there? And then I can just take the little triangle on that rectangle that we drew, bring it in so that it's in line with that step. In line with that step. There we go. Make sure you be really careful about that. And you can delete this one because that tread's no longer needed either. Okay. All right, cool. So that's kind of representing the first stage of the planter. I'm going to use the union command to group all of that together. So it's all one solid piece. Okay. And then we got to drop in the actual dropped in portion of the planter where the plants are going to sit. So we'll go back to the CAD model that was provided by the metal vendor and just take a look at what they are thinking we're doing here. See if we can get an idea of what it is that we're going to be providing for this. So go from that corner out to here. So it looks like they have a 12-inch setback from that side, a 12-inch setback from that side, 12. We'll call that 12. It's a little janky because I moved my cursor a little bit. Anyways, so it's 12 inches set in from the left, back, and the side, right? I guess right side. And then let's check how deep that they're making this planter. It looks like 12 inches deep. Okay, so 12, 12, and 12 is super easy to remember. We'll go back to our model. And then what we're going to do with that information is we're going to, actually, one sec. I need one more thing. One more piece of information. I need to know how wide this is from one side to this side. So 129 inches that way. Okay, the rest of the information I can decipher from what I have currently. So 129 long, 12 inches set in from each side and 12 inches deep. All right, so let's do some math here. We'll see what we can do. We got a platform of 70 inches. So if we take that into account, 70 minus 12 and 12, so 70 minus 24. So we have a 46-inch wide rectangle. And then we said that it was 129 inches wide, or deep, whatever you want to call it that way. So let's draw one in. We're going to draw a rectangle at 129 by 46. double check. Yep, that was right. Okay, cool. What I'm going to do with that is I'm going to press pull right off of this 12 inches. Get me a nice rectangular box. And then I'm going to take this box and I'm going to move it so that it's sitting just like this. It's right dead center of these 2 points. And then I'm going to slide it using the move command 12 inches this way. Okay. Then what I can do with that is I can now subtract that from the planter. Should be left with something like this, which again, this is a basic model. There's no framing in it. There's no, right now there's nothing in there that really represents any of the construction of the planter. This is more of like a shell or a base representation of that planter. I can go back and actually start to add in more detail for it, but I'm going to leave it for right now. And let's see if there is a material finish on there. It does not look like there is. So for right now, I don't want to put it on the rib layer, but I think I am going to put it on a layer. I just don't know what to call this just yet. Let's call it spice for right now. The spice layer is mostly used for like fancier stuff like models or figurines or outlets and different things like that. But right now I'm going to use it for the planter because I don't have a better layer to really put it on because I don't really know what the material is. It could be painted, it could be solid, it could be veneer even. I mean, there's really a million different things it could be, but we don't really know yet. So I'm going to leave it alone as it is. Okay. And so as far as on-site scope goes, we have constructed all of what we are intending to provide for the staircase at this point in time. But it's also important to try to represent the other people that are the other trades scope that goes into this too. So I know that that's kind of a nuisance sometimes because like a staircase, you have a lot more detail to have to add in. Looking back at like what's in the stair shop drawings or their model here, if I zoom out a little bit, like some of the things that we're going to be trying to add in, we're going to try to add in things like this handrail. And we don't have to go completely crazy with, drawing in like every little like tidbit of information. Like I'm not going to include that hardware, but what I am going to include is like where these posts come up. And I'll try to include like these little steel beams or steel connectors that go between. Now, the reason that I need to include that is because it does technically interact with what we're building. I don't know if it's shown very well here, but there is going to be, let's see if I can unhide or maybe hide this object so you can see better what's going on in here. So there will be bolts below that that plate, which are going to go through our tread into the metal plate that's inside of our tread. And because that does interact with our scope, that is why it's kind of important to show those posts and where they're located. That way we can plan ahead for where these bolts need to go and be drilled through our treads. So when you have interacting scope, it is important, even if it's not scope that onsite is providing, it is important to show it because it does interact with what we're building and it could make the difference between like leaving the next person in the dark or giving them exactly all the information they need to be able to move forward with their step in the process. So if we were to just draw the stairs without any handrails or anything like that, the install team may see that and they may be scratching their heads out there looking at it like, okay, but where am I supposed to drill these holes? Because, they don't really know because we didn't provide that information. So I want to try my best to provide them with as much information as I can to make their jobs easier with, the exception of like, I don't need to go and draw in I don't need to go extremely crazy and draw in a crazy amount of detail for some things, but when it comes to things that interact with our scope, it's important to show it. So, so let's see. We don't have any scope up top except for that one tread, so that's cool. I think what I would like to do is kind of figure out where these posts are located, maybe draw one standard post and then copy them throughout where they need to go. And then once we have those posts located, that should be able to help us with deciding where to or how to show these steel connector pieces, and also like if we want to show the handrail and all that, that'll help us with locating all of that information. So um, I want to show those. I also want to show this information here too. These metal stringers that sit below our stairs. Ultimately, those are what is supporting the weight of people walking up and down these stairs. And so because that is all sort of interacting with what we're doing too, I'm also going to try to do my best to make sure that I'm accurately showing that in our drawing as best as I can. I won't be dimensioning locations of these or the dimension of the stringer or anything like that on our drawing, but I still want to show it accurately. So for us to do that, let's see, I don't know if I want to start with the stringer, if I want to start with the handrail, but I may start with the stringer here just because it's going to be a little easier to roll with that. And then that'll help us with being able to then figure out more like the angle going up the stairs and all of that. So let's start with that. We'll go back to our drawings from the steel vendor. Close out of that too. Okay, so the steel vendor here does provide a nice level of detail as far as like what they intend to provide for that. The stringers they're calling out to be 1'2" or 14 inches tall. And then if you look even closer, they have a little leader pointing to it that says it's 6 inches wide by 14 inches tall. And it does follow the path of the staircase. So that's important to remember too. So we're going to go ahead and draw those in next. We'll be starting with just drawing the basic steel tube off to the side, and then we'll go ahead and use the align command to be able to line it up with where it needs to be on our staircase here. Oof. Ooh. Mm-mm-mm. Hmm. Okay, sorry, just checking to see if I have anything new in my inbox too while we're talking. Greg had just sent me this, but I don't know that it really. Oh, look at that. You can kind of see the stringer there. That's cool. Okay, cool. I think that makes sense. All right. Oops, I didn't mean to do that. I meant to split screen this with the actual drawing that we're providing here so we can kind of take a look at that. Whew. And I'm going to save it again here. Okay. All right, so let's draw on one of these stringer beams. So I'm going to make it some arbitrary distance. We'll just make it 300 inches in length. And we're going to make it 6 inches that way and 14 inches tall. Now, I could round these corners because in a real like situation, that's probably going to be rounded. But I think in this case, it's going to be more difficult for us to be able to actually align these if they have filleted corners. I'm just going to leave them as square corners here. All right. And then it looks like, for the most part, these are going to be 1/2 inch wide or 1/2 inch thick. I'm sorry. So we can use the shell command to be able to hollow this piece out. So I'm going to do that now. If you're in your solid editing toolbar in AutoCAD, you're going to click on solid up here and then go over to shell. Should be in your solid editing group. You click on that, select your 3D object here, and then it's going to ask you what faces you want to remove. It's real important that you select the right one. So we're going to select that face there. And we're going to select this face right here. once we've done that, you can hit enter, tell it that you're done selecting faces, and then it's going to ask you for an offset distance, which in our case is 1/2 inch or 0.5. Hit that button there, hit exit, and it will essentially hollow out the steel tube for us. You could do it a different way too, like you could easily just shell it out yourself, but there's a command in AutoCAD that's designed to do that, so you don't have to worry about like having to manually do all of that. All right, because this is something that we are not providing, I'm going to put it on the by others layer. All right. Then from there, I need to figure out where the heck this is located. So let's see. A4. A-04. What page is that? I'm on 02. I was hoping they might have a dimension here to show you like how high up the tread is from the stringer, so we can get that figured out and put in the right spot. Because they don't show one here, I'm gonna try to scale it my best of my ability and try to get this located correctly. So while I do that, what I'm gonna do is take a line straight down, just like this. I'll take a line straight down here, just like this as well. And then I'm gonna take a line that matches what's going on here. Because what I wanna do is figure out, okay, at the back of my tread, what is the height from the top of the stringer to the top of the tread? So let's do that. We'll scale it here. Go to custom scale, because this isn't one of the presets in Bluebeam, unfortunately. It's 3 inches equals a foot. So I need to go over to custom, type in 3 inches, and then come over here and say 1 foot 0 inches. So I'll change my precision a little bit. And I'm going to try to scale this here to see what we can come up with. It looks like, come on, 1 3/16, and then what are we dealing with at this spot here? 8 3/8. Okay, and then one last spot. I'm going to check in the middle. Okay, 4 3/4. I might roll with that because it's going to be easier for us to locate that dimension versus the other two because they are kind of oddball dimensions. So let me go back to this, get that over there. Okay, cool. So we got a beam. We also got our treads. So first thing we can do is we can use the align here. Well, let me make a copy of the beam first because I don't want to destroy the original just yet. All right, we're going to use the align command and select one of our beams. And what I'm going to do is click on the endpoint, so right here, and I'll click on the center point of one of my treads. So we'll go to the midpoint there, and we'll pick a point on the same line of that beam, so right there, and I'll pick the next midpoint of the next tread up. Okay, so that's going to give me the correct angle for this to be placed. And then what I need to do is drop it down 4 3/4 to get that dimension there. So 4.75, just like that. Okay, then because it is in line with the edge of our treads, I think it is set in a little bit. So we need to figure out how far in is it set. No big deal. Let's see if we got a dimension somewhere here to work off of. Otherwise, we have our little nifty model we can look at too. Ah. Oh, right here. How cool is that? 6 inches in from the side is where this lives. So we're going to click on our move command, move this guy over 6 inches this way. Okay. That gives us the location of our first stringer. Well, first part of our first stringer. So um, again, just like we did here, we can copy this. Instead of having to realign it, we can just recopy it over, kind of like that, using the base point of the thread above it to line it up just right. So then we have to connect these two together. And let's take a look at where that's fit. So underneath the landing, the stringer actually flattens out with the bottom of the woodwork. So what we're going to do is copy, not copy to layer. Oh my gosh. We're going to copy another stringer. And I'm going to align this one to be in line with the bottom of the landing. Just like so. Using the align command again, of course. And then sliding this in that way, 6 inches like we did for the other ones. Okay, and you could probably see where this is going now. So what I want to do is use, like we have before, we're going to use the interfere command. I'm going to slide this down a little bit first, making sure I keep it in the same location. But what I'm going to do is use the interfere command, like when we did our faceted panel training. We're going to use that to get this nice little mitered edge here because we want it to match up here like what they show right here. So we'll use interfere to do that. Click on one beam, hit enter, click on the next beam, hit enter. Oh, there it goes. Say pending AutoCAD doesn't crash. Uncheck the delete interference objects command and hit close. Should be left with a oddball little diamond shape in the middle. No big deal. We'll use our 3-point slice here to actually chop these apart right at that miter. Just like that. We can delete any parts that aren't relevant to what we need. So we'll be left with something like that. We're going to do the same thing down here too. And because it was struggling last time, I'm going to save it. Make sure that it's, not going to lose anything if it crashes again. Interfere. Part 1, enter. Part 2, enter. And then keep the interference object, of course. So once we do that, highlight both of these, pull up a 3-point slice command, and we are going to karate chop that thing right in the middle, just like that. Okay, then any parts that aren't needed get tossed. Okay, so now we're starting to get somewhere. When we get to the very top of our staircase, you can kind of see that the stringer actually does stop. It doesn't actually miter back out again like what we've been seeing. We go to detail 05 on view, or page 05 view A. You can actually see what that looks like. I got to get to that page here. Is that zoomed in a little better so I can actually see it? Okay, view A. Looks like this guy here. Okay. I was kind of hoping they would give us the gap between that plate and the stringer. It kind of looks like it's about a 1/2 inch, but I can scale it if I need to. Let's check that out and see what we got going here. 3 inch equals 1 foot, 0 inches. Boom. All right, let's just check it and see what we got. Yep, a 1/2 inch. Cool beans. So between the stringer and the plate, which is a 1/2 inch plate too. So let's see. And it's, oh, that's interesting. Okay. So the math is going to start getting a little bit complicated here because the plate is a 1/2 inch thick, but it's sitting halfway below the tread. So really, when we go to draw this, gap. It's going to be a 1/4 inch because we're taking half of the half. So a 1/4 inch for that plate, and then a 1/2 inch gap. So it's 3/4 of an inch from the back of our top tread to where this stringer gets chopped off. Man, they're really making us do all the hard math today. Can't make it easy, can they? 0.75. All right, we are slicing this just like so. And that should actually get us to a nice place where we got that stringer pretty much modeled in. It does do some mitering down here below that planter too. And if I was to remove that planter from our view and look back at what they had in their model, you can kind of see that. It kind of appears as if it is, I don't know where. Oh, shoot. We'll have to figure that part out a little bit, I suppose. But it does kind of miter straight down at the floor at some point right there. So, so as it sits currently, once we have that done, we'll clean that corner up here in a little bit. But on top of that stringer, we should have these little vertical posts that mount. They're going to be welded to the top of those stringers, and then they are bolted in to the plate or through the plate into that there to keep the plate steady where it's going to be. They do actually show dimensions of that, I believe, somewhere. Right here, 4 by 6 by 1/4 inch carbon steel plinth. That's just a fancy word for they're going to put some steel on top of this. You guys want to take lunch or anything?
Well, can if you want. Don't matter to me.
Okay. I might give my voice a little bit of a break real quick. Not that it's not like I'm losing it yet, but I can tell my throat's getting a little sore from talking. So we'll take maybe like a 30-minute lunch here if you guys are good with that, and come back at, well, it's 12:38. So let's just say 12:40. Come back at what, like 1:10.
1:10.
Something like that. I know it's late for us for lunch, but it's like perfect timing for Jordan's lunch probably.
Yeah, a little early, but that's fine.
All right. I just wanted to make sure that I can get through the rest of the day without losing my voice here. All right. So I'll put a pause on where we're at for right now, and then we'll make a part 3 video that goes into finishing up the rest of the steel. And I'm going to see if we can get to plotting it today as well, if we can. If we can't, we can always plot it tomorrow. But I think we can at least get the full model of it probably done today. We've already got all the millwork stuff done, so it's just a matter of putting in all the fancy like detail work now. So, all right, we'll come back here at like 1:10 and continue on from where we left off then.
Sounds good.
Yep, I'll see you guys in just a little bit.
Yep.
All right.